Hey there! Let's take a dive into our biological world and discover anaerobic pathways and what they're all about. Within our world, humans and various other living organisms need oxygen to release life-supporting energy through the process of aerobic cellular respiration. The laws of thermodynamics demand the continuous supply of new energy so that cells may carry on their work that helps an organism survive and grow. In this way, cells work hard to harvest energy from external sources so that they may use this energy to build new molecules, transport chemicals, move around, and maintain other cellular processes. However, not all organisms depend on aerobic respiration to metabolize glucose. Some pathways can harvest this energy into ATP without access to oxygen from the surrounding environment. In enters anaerobic respiration. Two pathways fall under this umbrella: complete anaerobic respiration and fermentation. What's complete anaerobic respiration? Well, simply put, it's a series of reactions resembling those of aerobic respiration, like creating ATP through electron transfer phosphorylation. But the key difference between complete anaerobic and aerobic respiration is using a different final electron acceptor at the end of the anaerobic electron transport chain. Diverse prokaryotes have evolved to use sulfates or nitrates as their terminal electron acceptor, so no more need for oxygen. Let's take a look into the deep underground of wetlands and marshes. During anaerobic respiration, these cells use sulfate as the terminal electron acceptor instead of oxygen, resulting in the end product of smelly hydrogen sulfide instead of our typical H2O. Next up, we have fermentation, a common anaerobic pathway used by many different prokaryotic and eukaryotic cells. It involves chemical reactions following the process of glycolysis to convert pyruvate into waste molecules such as lactic acid or ethanol. Without these reactions, pyruvate would accumulate within the cytoplasm and stop the entire process of glycolysis. And so, there are two types of fermentation pathways used by organisms: lactic acid fermentation or alcoholic fermentation. Glucose is degraded by glycolysis into two pyruvates. Each NADH produced during glycolysis donates its electrons back to the organic molecule pyruvate, producing lactate. Did you know that the sour taste of yogurt is a result of lactic acid produced by bacteria living in the yogurt? A group of single-celled fungal organisms called yeast convert pyruvate into ethanol, a 2-carbon alcohol. It also produces a molecule of carbon dioxide and oxidizes an NADH for each entering pyruvate. This process is used most notably to make alcoholic beverages such as fine wines and beer. That's all, folks. Those are the anaerobic pathways. Hope you learned something.
Created using Powtoon.